Hello everyone, today is day 5 and today we are going to learn about method of false position. In our last class we have seen the bisection method. I hope you all remember. The bisection method, what we had is that suppose this is my function, f of x. So initially I will be determining 2 points. They will be one of them will be a positive, another one will be negative. I will try to make sure they are as close as possible to my original answer, which is this point. Once we have these two values, these are 1 and 2, what will I do is that I will find out the approximated value 3, which is basically the midpoint of 1 and 2. So I will be adding 1 and 2 divided by 2 and I will find it out. So I believe you remember, isn't it? This was bisection method. This was the bisection method. Okay. This was the bisection method. We found out the midpoint. Today what we are going to do is that today we are going to see the method of false position. I'm repeating myself once more. If you are a student of Assam Engineering College 2020 batch, only then see this video, or else this video will be of no help to you. Now the method of false position, it is also known as regular falsy method. This is a very prominent name by which it's known, or it is also known as linear interpretation method. Here a different strategy is used in order to find out the approximated root. And what is that strategy? Over here what we are going to do is that instead of just finding the midpoint, we will find out a straight line joining the 2 points, and the intersection of the line will give me a value which is closer to the real value. Let's see that with an example. Suppose this dark curve, it is my function f of x, and this is my first value, this is my second value. How have we found out this value? We have found out this value by trial and error method or by some known conditions. After that what we'll do is that we will find out a straight line joining them. So we will find out a straight line joining them. We know the equation. The mathematics has given us the equation to find out the straight line by 2 points. So suppose we have 2 known points, and we can easily find out what is a straight line, isn't it? So with that help of that, we are going to find out this equation of the straight line. Now on the equation of the straight line, we will put my y to be 0. In that case I will find out this value, this particular value. This value, I can find out this value. How will I find out this value? So please see the steps. First we will be having 2 values, one will be greater than 0, one will be less than 0, similar to the bisection method. Then I will find out the equation of the straight line by joining them. Then I will put y is equals to 0 and I will find out this. Now my actual solution was this, my approximate solution is this. Now what if in place of this value is over here? Then what will happen? Then my straight line, it will be nearer to my approximated value. It will be nearer to my value. Originally it was here, now it is over here. Similarly, as I move this particular straight line closer and closer, I will find out that it is giving me the actual value which is at this point. Let's see that with the example. This particular. What I meant was that is that suppose this is my equation of straight line. This is my first root, this is my second one. I will find out a straight line joining them. Okay, sorry. I will find out a straight line joining them. I will put y to be 0 and I will find out this. Now in place of this, now the next approximated root is over here, suppose. Then I will find out this value. I will find out I will find out this. So in this way I can find out my approximated. I hope you are able to understand it. Now this is the equation of straight line. So if the 2 points are known to me, suppose one of them is B, another is the value at B, and one is A, another value at a, then this is the equation of the straight line. By putting y is equals to 0, I can find out this. Now this equation you will find it in the books also. I have rewritten it in a different way. They are the same thing. It depends upon you how you do it. So in the regular Falsy method, I have my function. By using the trial and error method, I will find out x0, and I will find out what is the value of my y at that x0. I will find out x1 and what is the value of y at that x1. I will find out a straight line. Then I will put y is equals to 0 and I will find out my x3. This x3 is basically the approximated root. Now if this root, suppose this one and this one was my original values. Suppose this one was the first value, this one was the second value, and after doing the regular Falsy method, I found out the third value. Now as this 3 is more closer to my x-axis, so I will be using next this 1 and this 3. Now suppose after using them I got another value which is over here, then I will be using this and this. So in this way, you already know the drill how we do it, isn't it? So this is the same. Here the only thing that has changed is how I find out the approximated root. I have shown the derivation over here. I will give you this PDF so you can see it. You can do it yourself also. Now let's see an example. Now remember this formula, this particular formula which you are seeing over here, this formula, both of them are same only. This one and this 8.3, both of them are same formulas. This is the final formula after putting y is equals to 0. Okay. So remember this formula. It will be handy in order to do it quickly. Suppose this is my equation and I want to solve it. X e to the power x is equals to cos of x, and I want to use regular Falsy method and up to 3 decimal places, isn't it? Now this is a transcendental equation. Why? Because I have cos over here. For such kind of equations, please remember to use radian in your calculator. So remember that if you keep it in degree, then you will not get the accurate result, isn't it? So put the calculator on the radian. So this is my function f of x. This is what I have done. I have taken everything which is present on my right hand side over to the left hand side, and I have made my right hand side equal to 0. And my objective, what is the root? The root is that value of x for which this entire equation x e to the power x minus cos of x is equals to 0. That's how we find out, isn't it? So first let me put f of 0. I will be finding it minus 1. Then f of 1, it will be 2. So 1 is negative, 1 is positive. So I know that my value of x, the root is lies between 0 and 1. Now let me go deeper. Let me use 0.5. See, at 0.5 also I am getting a negative value. So I know that my value is the root lies between 1 and 0.5. Now again at 0.6, let me try. It is a positive value. What do you mean by that? Now I can conclude that my root lies between 0.5 and 0.6. Why? Because at 0.5 the value of x, f of x is negative, and at 0.6 the value of f of x is positive. So my root lies between 0.5 and 0.6. So these are the initial values. So x0 is 0.5, x1 is 0.6. I will find out what is this function, this f of x at x0, that is 0.5, and also at x1, which is 6. Then I will be directly using the formula, this particular formula only. This formula and this formula are same. This formula, just pure formula, just put it in the formula. How I found out this formula? I have found out this formula by putting my y is equals to 0 in the equation of the straight line, isn't it? I'm repeating myself once more. This is my function. These two are the initial values. This is the equation of the straight line, and what I have done, I have used y is equals to 0 and find out this value. Though my actual solution is over here, but I'm finding out this value, isn't it? I'm trying to find out this. I'm getting this. So in the next step, what happens is that. So what did I find? My approximated root to be. My approximated root is 0.5167, isn't it? And what is the value at that point? It is a negative. So you see, at 0.5 it is negative. At 0.51 it is negative. At 0.6 it is positive. So my root now lies between what values? Right, it's between point 1, 0.516771 and zero point 0.6. So what will I update? I will update my x naught value. Initially my x naught was 0.5. On 0.5 also I had a negative value, and now at 0.516 also I'm having a negative value. At 0.6 I'm having a positive value. So my root lies between 0.516. So that's what I have done over here. I have updated it. Again I have this, so I already know from the last one it did not change x1, but this changed, so I will find out what is the value of f of x1 at this particular value. Again I will be finding the approximated value, and I will find out what is the value. Again it is a negative, so what will I do? Again update this. The first parameter only I will update. So as you can see, by doing the 2 iterations only, I have up to 3 decimal places to be 0. See, it's over here also it is 3 decimal places, it is 0, it is, they are same, isn't it? Let's see, this x naught it is 0.517, and here also we have after calculator 0.517. So two values after 3 is very equal. Now why did I how did I got this value at the answer at such a short calculations? The reason is that because I in the initial stages I have taken it closer. Now suppose initially you could have taken your x0 to be 0 and x1 to be 1. If you would have taken this, in that case the number of steps required to find out the solution would have been more. But over here it did not. Why? Because I have gone deeper in closer to the root. So that's the whole idea. That's, you can try this. You can try for this equation also. It's not a sessional, but you can try it for you. I will give you a different session later on. So this is the algorithm. So I'm telling you once more. It's a very simple way. All you have to do is that you will be given a function f of x. You will be given that function f of x. You will find out the first two initial points by using the trial and error method. One of them will be positive, one of them will be negative. Then you will find out the equation of straight line, put y is equals to 0, or you can directly use this formula. It is the direct formula. This is the direct formula. This is the direct formula. Once you have this, you will see that the value which you are getting, whether it is in the negative zone or in the positive zone. If it is a negative, then you will update this. If it is positive, then you will update this. That's it. And then you will move on to the. So you have a homework. Use the first position method to find out this particular f of x e to x minus x3. F of x is equals to e to the power x minus 3x square equals to 5 decimal places. This is the solution, basic solution. Now here I will encourage you, while showing you, while in the PDF I have done the calculation for each and every steps. It is preferable that you use a tabular way of representation. In that way it will be better, but also you have to show me few calculations. It is not that you will directly just for this particular question will directly give me a table. You have to show me sample calculations. So you show few sample calculations, and after that you can do it on the table directly. So that's it for today. Do the homework and submit me. Thank you.